everybody, and welcome back to more rational root theorem fun. Now, this problem will probably take the entire page, so please be aware of that. You are going to want to start a new page for this problem. This one is awesome. Okay, so this has 5 terms in it. We don't have a method necessarily for factoring 5 terms, so we are going to have to use rational root theorem. Let's go ahead and start listing our factors. So I need the factors for the constant, which is 12. And I need the factors for the leading coefficient, which is 10. Feel free to pause and list all of your factors out. Then as soon as you are ready, log back in and match them up. So 1, 2, 5, and 10. There we are. And double check to see if you got them all listed. Okay, so the next thing I'm going to do is list all of my possible solutions. So obviously it'll be all of these divided by 1. So I know when I divide by 1, I don't change that number. So I'll go ahead and list all of these because they're divided by 1. The next thing I'm going to do is divide all of these by 2. If that number is already listed, then I'm not going to repeat it. Okay, so what I have here is I have 1 divided by 2. Okay, 2 divided by 2 is listed. 3 divided by 2, 4 divided by 2 is listed. 6 divided by 2 is listed. And 12 divided by 2 has already been listed. Then I'm going to divide by 5. Okay, so I have 1 over 5. Notice I'm using positive or negative for every option. Let's see, we have 2 over 5, 3 over 5, 4 over 5, and 6 over 5, and 12 over 5. So we're there. And last, I'm going to divide all of these by 10. So I'll have 1 over 10. 2 over 10 is 1/5. I've already listed that. 3 over 10. 4 over 10 is 2/5, and I've listed that. 6 over 10 is 3/5, and that's been listed. 12 over 10 is 6/5, and that's been listed. So I am finished. I don't need this last plus or minus. I've listed them all. Excellent. Okay, so the next thing I need to do is to start testing them. Okay, now when you're testing them, let's not be afraid to test the fractions. Especially if you're going to test a fraction, be sure you test one. I always choose one with a denominator that I'm really happy to work with. Like the number 2 is a denominator I really, really have no issues working with. So I'm going to test 3 halves. So negative 3 halves times 10, ooh, sorry, I forgot to write those out. 10, negative 11, negative 42, 7, and 12. Thank you. There we go. Now, 3 halves times 10 is negative 15. I'm going to add, I get negative 26. 3 halves times negative 26 is 39. Add, and I get negative 3. 3 halves times 3, we have 9 over 2. Negative, negative is positive. Add 23 over 2. Negative 3 halves times 23 over 2. We have negative 69 over 4. Add these two, we get negative 21 over 4. So this is our remainder. Obviously, that is not a solution. Negative 3 halves. Now I could test positive 3 halves. I'm not going to. I think I'm going to jump over and do like a negative 1/2. Negative 1/2. So, and I did make that kind of small, didn't I? 10, negative 11, negative 42, 7, and 12. Ooh, we crunching it up over here. All right, negative 1/2 times 10 is negative 5. Add negative 16. Multiply, we have negative 8. No, wait. Is that negative 8? No, it should be positive 8. Thank you, positive 8. So that gives us negative 34. Negative 1/2 times negative 3 is 17. That gives us 24. I'm running out of space. Negative 12 and 0. And feel free to pause at any of these moments and run this synthetic division for yourself. So I know that negative 1/2 is a solution. So I can rewrite my polynomial. It's now 0 equals x plus 1/2. And I'll use this to write the remaining polynomial. So 10x to the third minus 16x squared minus 34x plus 24. Oh, and all of that's equal to 0, of course. Okay, now you might want to take a minute and try to factor what's this remaining polynomial here. I will give you a hint. It does not factor. So since it does not factor, I'm going to run rational root theorem again. When we run it the second time, we're going to run it for just this polynomial here. So when I'm running rational root theorem again, I'm only doing it for this polynomial right here, okay? I'm doing this without regard to the first polynomial. All right. So I need all of the factors of 24, and I need all the factors of 10. Okay, so go ahead, take a minute, and you know what? See, I'm looking at this polynomial here, and I could have reduced it. I think I can factor out a 2, a GCF of 2 here. Yeah? Let's go ahead and do that. You know I love pulling out a GCF because it just makes my life so much better. I like small numbers in my problems. I like small numbers in my pant sizes. Okay, so let's factor that out. Let's go ahead and do that. So if I factor that out, I have 0 equals 2 times x plus 1/2 times, okay, and I'm going to factor out the 2. So I have 5x to the third minus 8x squared minus 17x plus 12. Oh, I like these numbers better. Then let's run rational root theorem on this guy right here. Yes, let's do that. Absolutely. Okay, so I need all of the factors for 12 and all of the factors for 5. Now that is great because the factors for 5 are 1 and 5. So let's see, for 12, we have 1, 2, 3, 4, 6, and 12. Excellent. Okay, so take a minute, feel free to press pause and see if you can list all the possible solutions by yourself. As soon as you're ready, press play and double check. See if you got them all. Excellent. Okay. Let's see. What should we start testing? I'm going to test 3 over 5. Let's test 3 over 5. All right, 3 over 5. Okay, so I'm going to set up my synthetic division. Notice I'm using this polynomial now. I am not going back up to the top. I'm using this one right here. All right, so I have 5, negative 8, negative 17, and 12. So I'm going to run this one more time. Okay, so I have 3/5 times 5 is 3. Add those and I get negative 5. 3/5 times negative 5 is negative 3 and I get negative 20. 3/5 times negative 20 is going to be negative, let's see, 12. Woo! And, oh, look at that. I have a remainder of 0. I'm very, very happy. All right, so 3/5 is my next solution. So I have a solution of 3/5. So I can rewrite my polynomial one more time. So this polynomial is 2 times x plus 1/2 times x minus 3/5 times 5. Excuse me, I should have put the 5 first because I'm getting the 5 from here. Okay. So 5x squared minus 5x minus 20. Okay. I can factor a 5 out of that one. So if I factor a 5 out of that, I put that over here. Okay, so let me factor out a 5. 2 times 5 is 10. Okay, these will stay the same. So let's factor out a 5 right here. So I'd have x squared minus x minus 10. Now that is relatively easy to factor, I think. Let me see. Oh, you know what? That doesn't factor at all. 10. That's not a 10. That's a 4. We are struggling. That's a 4. Sorry. 5 times 4 is 20. Yeah. Okay. Still doesn't factor. This is not factorable because if I set this up, I would need 2 numbers that multiply to give me -4 and add to give me -1, and there are no, that's just not going to work. Well, that's okay because this is x squared, which means I can use quadratic formula. So just a second, for those of you who have forgotten quadratic formula, so I have x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. I'm just going to use quadratic formula on this quadratic right here. So x equals -b plus or minus b squared, so -1 squared is 1, minus 4 times a times c, divided by 2 times a. Okay, so that gives me 1 plus or minus the square root of 17 over 2. And the reason, of course, that wasn't listed before is because this is irrational. So I was going to have to use quadratic formula to find it. So now I have all 4 of my solutions. I knew there would be 4. I have all 4 of my solutions here. So I have x equals, we could have -1/2, +3/5, 1 plus the square root of 17 over 2, and 1 minus the square root of 17 over 2. We have found all of them. How fun was that?